Venn diagrams and complements. Worked example. If you're going to school, you will either go with your father or your mother. The probability of going with your father is 0.6. What's the probability that you will go with your mother? So to represent this information and answer this question, it's usually best to draw a Venn diagram. Now, a Venn diagram is a way to represent the relationship between sets of different events. So when we draw our Venn diagram, it's usually best to start off with a little rectangle that represents our entire sample space. So this rectangle represents our sample space. And you'll usually see a sample space denoted with the Greek letter omega. And this is all of the events that can occur. So this is all of the possible events. So this is everything that can happen in our model, in our situation, in this reality that we have created. So this is our sample space. The probability of the sample space, where we use this P to denote probability, always has to be equal to 1. It's because something has to occur from the sample space. It represents all possible events. So in this scenario, you can either go to school with your father or your mother. So we let F be the event that we go to school with our father. So let F be the event that you go to school with your father. So how we represent this is we draw a circle. And this circle represents the set of all the days or all the scenarios where you go to school with your father. Then there are also days where you will not be able to go with your father and instead you'll be going with your mother. So you will let M be the event that you go to school with your mother. So when we are dealing with Venn diagrams and any probability or statistics questions, it's usually good practice to write down the key or the legend of what your symbols mean. F means we're going with our father. M means we're going with our mother. So this circle over here represents the set of days or events where we go to school with our mother. So the probability that F occurs is the probability that we go to school with our father. That's said to be 0.6. And assume that we can't walk to school and there's no other alternative and that our parents don't drive together to school. They have two separate vehicles which they go to school with. So you can either go with your father or with your mother. There is no alternative and they're very strict. They won't allow you to stay home. So you have to go with your father or you have to go with your mother. So the idea of a complement of an event is what will be useful for us to answer the question, what is the probability that we'll go to school with our mother? So the probability that we go to school with our father plus the probability of this event's complement, FC, or people can write F dash to be the F complement. So a complement means that it's all the events where we don't go to school with our father. So we either go to school with our father or we don't go to school with our father. And since probability has the property that it has to add up to 1, the probability that we'll go with our father plus the probability that we won't go with him has to add up to 1. So that means the probability that we don't go with our father, F complement, is equal to 1 minus the probability that we do go with our father. So in this case, is the probability that we go with our mother will be equal to 1 minus the probability that we go with our father, which is 0.6, which leaves us with the answer of 0.4 is the probability that we'll go to school with our mother.